All right. So, okay, right. So I think the recording has started. All right. Okay. Uh, since there are very less people right now, so okay. So there were a lot of questions last time. Okay. So I thought, even though people are not here, maybe they are busy with some work. What I will do is I will try to clear few doubts that were there in the last tutorial. And what I will do succinctly is that after that we will try to solve the week 1 and week 2 assignments and see like what should have been the method to solve these problems. Okay. So let me just share my screen for. Okay. Okay. So I think this is shared. Okay. Okay, so okay, there is only one person, Rehan, if I spelled it correctly. Nonetheless, I will get started, and I will first I will solve the previous tutorials doubts, and later I will sort of go over week 1 and week 2 questions. And if you guys have any questions, you can ask me. Okay, so hello, namaste, and welcome everyone. Welcome to this tutorial. In today's tutorial, we are going to see is like we will try to first solve some doubts that were there in the previous tutorial. But since I was not allowed to discuss week 1, week 2 assignments, I was sort of hesitant to solve those. Nonetheless, I had given a lot of hints, and after that we will get started with our regular week 1, week 2 assignment problems and see how they were supposed to be solved and things like that. Okay. So okay, so first of all, let us get started with all the doubts that were there. Okay, so I think there were two doubts. Okay. So we'll solve those doubts. And there were some questions, some people were asking me to solve some numerical problems, since I will anyway be solving week 1 assignment problems. I think we will sort of take that part in the assignment solving part of today's tutorial itself. Okay. So okay, so what the first doubt was, someone was asking that, okay, in MP neuron, okay, uh, what if one neuron is inhibitory. Okay, so this was the question, and as I had discussed in the previous tutorial itself, I had actually told this that okay, in MP neuron, the idea is that even one of the neurons is inhibitory. It will act as a switch, and it will turn off the output of the neuron. So no matter what the value of that particular neuron is, even if one neuron is if it is inhibitory, no matter what the value is, it will turn off the neuron, and yeah, the output will be 0. Okay. So I hope that this is clear. Okay. There was another question someone asked me after uh, after the lectures. Okay. So that question, so the doubt was as follows. Okay. So here was the problem. Okay. So let me draw something, few things. Okay. So it was from the lectures. Okay. So there is something like this that is given here. Let me just copy this thing. So there are four neurons. Okay. Okay. So I'm sorry, I'm being a bit hasty there. Okay. So there were four neurons. There you had two inputs, x1 and x2. Okay, and there was a final output, which was this thing. Okay, right. And you had this thing, right? Okay, so you had some connections here. So each neuron was sort of connected. So each input was connected to every neuron here, and similarly you had these connections as well. Let me use another color. Okay, and after that you had another neuron. So all of the intermediate neurons were connected to this final neuron, and the thing was that you were given something like this: -1, -1, -1, 1, 1 -1, and finally 1 comma 1. So and the output of here was h1, this was h2, h3, h4. This was w1, w2. So these were the weights that were assigned to each of these individual neurons, and there was a bias term which was -2. Okay, and there was a truth table. I will Let me draw that truth table. So there was a XOR operation that we were trying to see if. Okay, so I think let me manage some space here. H1, H2, H3, H4, and it, then here was something called summation WIHI. Okay, and you had 0, 1 here. Sorry, it was 0, 0, 0, 1, 1, 0, 1, 1. The XOR operations output were someone is entering. The XOR operations output would be here it will be 0, it will be 1, 1, and again 0. So XOR operation wants your inputs to be basically it is all the inputs should not be equal is what the XOR operation is. So okay, so let me sort of illustrate what is going on here. So you have two inputs here, x1 and x2. Okay, and so so what does this thing imply, right? So what does -1 comma -1 written here in this neuron, what does this imply? So basically okay, so here it is. So this implies that this neuron will fire only when x1 is equal to -1 and x2 is equal to -1. Here -1, okay, let me write this -1. Okay, people are joining. Okay, no issues. So -1 is a sort of proxy for 0. Okay, so this should be kept in mind while solving these problems. Okay, so instead of 0 we are using -1 as the symbol. Okay, so it's just a convention that we are using. You could have done it with 0 itself, there's no issue, but for the sake of simplicity people use -1. Okay, all right. So this is what it tells us. Okay, so the h1 neuron will fire only if your input is -1 comma -1, or in our notation it should be 0 comma 0. Okay, so only when both your inputs are 0, h1 will fire. Similarly, what does h2, so this, what does -1 comma 1 imply? It implies that okay, h2 neuron will fire only when your x1 is -1 and x2 is 1, or in our convention when x1 is 0 and x2 is +1. Okay, that is all it means. So okay, so let us see. Okay, So let us write down what are the values. So if so here, okay, so let's see. So x1 x2 here are 0 comma 0, okay, which means it, they are minus 1 comma minus 1 in the neural networks convention, okay. So when the inputs are minus 1 comma minus 1, which neuron should get activated? So you can see here, right, that h1 will get activated, and rest all of them will, they won't fire, so they will be inactive. So here the output of h1 will be 1, other outputs will be 0. Similarly, when your x1 is 0 or minus 1 and your x2 is 1, which neuron will fire? Okay, more people coming in. Okay, so when your x1 is minus 1 and x2 is plus 1, which neuron should get activated? You can see here. So this H2 neuron will get activated essentially. So H1 will stay off this time. This will get activated. The rest of them will stay off. Similarly, you can see that 1 comma minus 1. This neuron will be activated when this condition is satisfied. Hence, these two would be 0. This will be 1. This will be 0. Similarly, the last will be this thing. Okay. And yeah, so this is how the truth table. So the major doubt was that, okay, how did we construct this truth table? Okay, so this is how we constructed the truth table. So we have conditions for each of the neurons to get activated when so, and the conditions are sort of denoted by this, the numbers that are written inside this neuron. And as soon as that condition is satisfied, that neuron fires. That's all. So it's a simple thing. And finally, what is the output of the, so okay, this is fine. So we wrote what, when, which neurons are going to fire here. But okay, then we also need to see that, okay, what finally will this neuron output? Okay, so this is the, like the final neuron. What would its output be? So I hope that you will agree that since W1 is getting multiplied by H1 here, and H1 is 1 in this case, and rest of them are 0. So H2, H3, H3, these are all 0. So they won't matter, and only W1 will sort of multiply with H1, which is 1, and you will get W1 as output. Similarly, you will have W2 here, W3 here, and W4 here. Okay. So like this is the table. This is the way that table was constructed. And and since it is a, so this is, since this is a one layer uh, so since this is a one layer perceptron sort of thing, and you have this thing, right, that the condition for the final neuron to fire is the following, right? So final neuron will fire when. So when will it fire? You have this condition that summation wi hi should be greater than or equal to w naught. So w naught is some bias term that you will decide depending on which function you are trying to approximate. And so okay, so we see that, okay, yeah, the XOR operation here is in these two conditions are 0. So the final neuron should not fire in these two conditions, right? So what does it mean? So okay, so let us write all these conditions. So this means that W1 should be less than W naught, okay? And the final thing, this condition should also be satisfied, which means W4 should be less than W naught, okay? Next, we have that these two outputs should be 1, right? And the summation, the aggregator functions output here is W2 and W3. So these two, W2 and W3, should individually be greater than the bias term, which means that W3 will be greater than or equal to, should be greater than or equal to W naught, and similarly W2 should be greater than or equal to W naught. And so any tuple of any pair of any tuple of W1, W2, W3, W4, and W naught which satisfies these conditions are like valid weights that we can use to construct this one layer perceptron. All right. So this is the way this thing was constructed. Okay. So I think one person had doubt in this thing. So I hope this doubt will be cleared. though I cannot see that person here. Yeah. Okay, okay, so anyways, okay, so now let's get started with week 1 and week 2 assignments and the corresponding solutions. Okay, okay. So all right, so okay, so let's solve week 1 assignments. Okay. Okay, so let us see all the questions. Let us start one by one, and if you have any questions, you can just speak out since there are very less people today, only one person actually. So, if you have any question, you can just unmute yourself and ask me any question if you have. Okay. So, okay, so let's see what the first question is. So the first question is, so the question asks you which of the following functions can't be learned by the perceptron algorithm. Okay, so there are four options that are given. Let me write each of them. OR function, B is AND function, C is XOR, okay, and D. Okay, D is not. Okay, okay, so so whenever you see these types of questions, the best thing to do is, just create a truth table and using the truth table, plot all of these functions. That's the like go-to method. It once you get hang of it, you can do these things even in your mind. But nonetheless, let me do two. Let me illustrate two of them. One would be the one option would be a function which you can learn using a perceptron algorithm, and one would be a function which you cannot learn using perceptron algorithm. So let's see. Okay, you have, let's take from these two. Okay. So again, someone. All right. So let us see. Okay, so yeah, we'll use the same color. Okay, so let us see. Let us check out for, let's see, B, AND function. What happens with AND function? Okay, so let us take two inputs. Okay, let's say x1 and x2. Okay, and let us see the AND output. What is the AND of these two? And accordingly we will see whether a perceptron can model this function or not. So the possible inputs are 0, 0, 0, 1, 1, 0, and 1, 1. Okay. The AND will be true. AND function will give 1 only in this case. In all the other cases, it will give 0. Okay. And if we plot this, okay, let us try to, plot it. So we will see what the, let me copy it for future references. Okay, so when it is 0, 0, so this is 0, 0, this is 0, 1, this is 1, 0, this is 1, 1. Okay, and you are given that the AND function is true only in this case, right? In all the other cases it is dormant. So this won't fire, this won't fire, and this won't fire. And now we can see that, okay, this function is actually linearly separable, right? I mean, you can draw a line like this, yeah, and it can linearly separate these two sort of labels, and hence, since any function that is linearly separable can be learned using the perceptron algorithm, and function will go through, and you will be able to see that, okay, this can be learned. Okay, actually we saw in last I think in the uh, uh, last tutorial that how we can do that. Nonetheless, let's move forward. So if we see the C option, that is XOR, okay, let us construct a similar truth table. So what will be the output and so on. So these are 0, 0, 0, 1, 1, 0, and 1, 1. Okay. The XOR option wants the XOR option basically wants none of your inputs to be both, none of your inputs to be same. Okay, so okay, this one actually so you can see x1 x2 are not equal here. You can see here x1 x2 are again not equal, so it will give you 1, but here they are equal, so it will give you 0, and here also they are equal, so it will give you 0. Okay, uh, constructing the truth table, I hope you are already familiar with how to create these tables. This is, if not, just ask me. So this is 0 comma 1, this is 1 comma 1, and so when does this OR function gives you 1 as output? So this was 0 1 and 1 0 are the cases where your in the output of XOR is 1. In all the other cases, this one and this one, your output is 0. So you can see that there is no linear line that can sort of separate these two. Any decision boundary that you can think of will be non-linear, okay. So what do I mean by that? So it's like something like this, right? You need something like this to sort of uh, classify the two labels. So anything inside this ellipse is like 1, and anything that is outside this ellipse is 0. So you will require something like this, and since it is not a linear hyperplane, you will see that you cannot learn this function. Okay. uh, so okay, so this was again a easy problem. I illustrated it a lot, but nonetheless I hope this is clear. So XOR is the option basically. Okay. Now coming to the second question, which is, okay, so the second question, it asks you which of the following statement is true. Okay. So let me just write. The first option is perceptron can be used to approximate any function to the desired precision. The okay. The first option is perceptron uh, can be used to approx any function to desired precision. So okay, so this statement is I mean, as we have repeated several times, perceptron can only approximate a function which is like linear. Okay, any function that is not linear, a perceptron cannot basically uh, approx that. Okay, so this is an incorrect statement. Okay, let us look at other options. There is a B options which says a single layered network of neurons can be used to approximate any function. A single layered network can be used to approximate any function. So again, so a single layered network will only have the input layer and the output layer. Okay, and since there is no sort of hidden layer, again this will, you can see, okay, so it will be like some inputs are there and they are connected to one output. Okay, something like this, and you will have some output. So if w are the weights here and x is the input, so again you will have some w transpose x kind of thing. Yeah, and this is again linear. Okay, again you cannot approximate any function to desired precision. Okay, you will incur some error, and so yeah, so again this statement is also wrong. Okay. Coming to third option, third option is a multi-layered network of neurons with a single hidden layer can approximate any continuous function to the desired precision. So this says a multi-layered network with single hidden layer can approx any continuous function. Okay, so this statement is actually what is called as a universal approximation theorem. Okay, so let me write that down. So this is what universal approximation theorem. Okay, so universal approximation theorem, or UAT in short. So UAT actually tells you that okay, if you have a single hidden layered neural network, or yeah, single multi-layered network with a single neuron as output, but there is a hidden layer. With this network, you can approximate any function, any continuous function, so to say. Okay, and this is something that this UAT tells you, and hence this is the correct statement. Okay. So I hope, I mean, it is just if you remember UAT, you can simply you can straight away like tell what the correct statement is. And there is another fourth statement which says multi-layered networks with multiple hidden layers can't approximate. Uh, Let me write multi-layered networks with multiple hidden layers can't approximate continuous function continuous functions. So this is not true. Okay, I mean UAT tells you that okay, even if you have a single hidden layer, you can approximate it. And you can think that if you have multiple hidden layers, okay, if you have multiple hidden layers, you can always approximate it. You can always approximate any continuous function. If one hidden layer can do it, then multiple hidden layers can definitely do it. They can even, approximate even more complex functions. So okay, so this is not correct. Okay, because there is a can't here, so it can actually. Okay, this was the second question. If you have any doubt, I don't know how many people are here. A single. So yeah, if you have any problem or any doubt, Sahitya, if I spelled it correctly, you can just ask, unmute yourself and ask. Okay. So this was the second question. Let us look at the third question. So this question asks you, which of the following architecture has a capacity to solve complex, long time lag tasks? Okay. And the options again here are, there are four options: C, D, um, out of which the two that are of interest are RNN and LSTM. The other two you can look at it, and they are like Hopfield networks and Elman networks are not desired here. RNN and LSTM both solve long time tasks. However, RNN suffers from something called uh, vanishing gradient problem, and hence it is not it cannot it cannot solve complex long time lag tasks. Okay, only so the only correct option here is that of LSTM. So these are just like GK questions. Okay, like you just remember things and sort of answer it. Okay. Okay, so fourth question is, you have a okay, someone has joined. Okay, so the fourth question is that you have a MP neuron. Okay, there is an MP neuron, right? And you have which takes x1, x2, x3, x4 as inputs. So there are four inputs. Okay, so there are five inputs actually. X5 is also there. Okay, and you are given as threshold theta, which is equal to 3, and it is given that x5 is inhibitory. Okay, so, and it is asking which of the following statement is true about the input output y. Okay, so remember x5 is given to be inhibitory. Okay, So you see, as I told earlier, right, that even if one of the neurons is inhibitory, the output will be zero. So as soon as you see that, okay, one of the neurons is inhibitory, don't think about anything. Just you can say that, y, which is the output. Okay, the output is going to be zero. So only the first statement which says y is equal to zero is the correct option. Okay. So this was again easy problem, I hope so. Okay, so now there is a fifth question. Let me just check here. Yeah. Okay, so now let us go to fifth question. The fifth question says, asks you an MP neuron takes two input x1 and x2. Its threshold is theta equals to zero. Okay. Select all Boolean functions this MP neuron may represent. Okay. So this is again like simple question. Okay. So okay, let me, whenever again, whenever there is question related to, Boolean functions or things like that, just create the truth table and everything will be clear to you. Okay. Okay. So let us see. So there is x1 and x2. Okay. First of all, since not is a function that takes only one input, it cannot be modeled using two neurons. Okay, so that is something that you can directly reject. So not, should I write it? Maybe I can write it. So uh, let me just keep it here. Not takes only one input, hence this is rejected. Okay, reject. The not cannot be modeled using this MP neuron. Okay, and then you have been given AND function, OR function, and NOR function. All right. Okay. So and since MP neuron aggregates the inputs, let us also write what is x1 plus x2. Okay. So that we are clear that what the aggregator function is going to be and things like that. Okay, so let us sorry. Okay. So this is here. Uh, Let me draw these lines just to make sure that this is okay. Okay, so what are the possible inputs? 0, 0, 0, 1, 1, 0, 1, 1. Okay, and function will assign 1 only to this case, others will be 0. Or function wants at least one of them to be 1. So this will be 0, rest of them will be 1. NOR function is just the complement of OR. So wherever OR gives 0, it gives 1. Rest of them, it will give 0. Okay. Now let us see what x1 plus x2 is. It is 0, here it is 1, here it is 1, here it is 2. Okay. And let us see that, okay, what will be the output y, okay, in this case. What will be the output y? Y, the output will be, the threshold here is given to be 0. So whatever is, above 0, it will assign 1. And whatever is less than or equal to 0, it will assign 0. So this will happen. Okay. Now let us see. Okay, using y. So ultimately I will get this as output. Okay. So using y, which of these functions can I model? Okay, and or not. Okay, let us see. So let us see and function first. Okay. So when y is 0, and is also 0. Okay, fine, cool. I can live with this. When and is 1 and y is also 1. Okay, this is also fine. However, in these two cases, when y is when and is 0, y is 1, right? This is not good. Okay, like this is not. We cannot use this to model and right. Similarly, if you take C or gives 0 in this case, so this works. Someone is trying to join. Okay. OR gives, when the OR output is 0, Y is also 0. Okay, fine, this is good. When OR output is 1, uh, this is also 1. Okay, so this is also fine. This will also work. And uh, yeah. So, have I made any mistakes? Uh, right. So I think it's fine. So when OR is 1 1, this is 1 1. Okay. So I think OR can be modeled using Y, right? There is no issue. You can use OR function. So you can use this output, use this MP neuron to model your OR function, right? If you look at NOR function, if you look at the NOR function, right, it gives 1 when your Y is 0, okay? And it gives 0 when your Y is 1. So actually, if you see, Y NOR is nothing but this is Y's complement. So if you take Y and just take complement of it, you will you will be actually able to recover NOR, right? So both NOR and OR functions can be modeled using this MP neuron, right? So this is the like the explanation for this question. Okay. So then there is sixth question. The sixth question, what it tells you is, it asks you which of the following decision boundary given by red line represents the AND function learned by MP neuron for two inputs x1 and x2. Okay. So again, whenever you are dealing with Boolean functions, just create the truth table x1, x2. Now I have made it several times. Let me just do it. 0 1 0 1 0, it will be 0 1 1, it will be 1. This is the sort of template, always make this. You have this coordinates, uh, just create 0 comma 0 is here, this is 1 comma 0, this is 0 comma 1, and this is 1 comma 1, right? So now AND function only assigns 1 to this point, rest of them it assigns 0. Okay, so all of the others are 0. So whichever function sort of is able to any function, any line that is able to separate these two can is a valid boundary that can be learned using a MP neuron. Okay, so the first option sort of takes a line that goes from here, right? So this is not correct. Okay, the first option which takes this line, this is not correct, since these 2 points are on the other separate different sides of this boundary. It is not correct. Yeah. Okay. Then you have yeah. So then you have another function. Okay. Yeah, so then you have another question. Another option is what? You have a line that goes from. So there is one line that I can see here, which goes from, this is some point 0.5, okay, and there is a line that goes like this. So essentially, this is the boundary that one of the option tells you. Well, this option is no good either, right? Because again, this point and this point are on the other side of the decision boundary, and hence they are misclassified, and this is not what a MP neuron will learn. Okay. Then there are two more options. One of them is this line, exactly this line. Yeah, wait. This line. Okay, now this is a tricky one, right? This line seems to be correct because it assigns some. It might look that these 3 points which are supposed to have a label of 0 are on the same side of the MP neuron, whereas this one is on the other side. However, remember that whenever the condition for MP neuron is that it will assign. So what was the condition for MP neuron, right? So the condition was summation wi xi. If they are greater than or equal to theta, the output is 1 and it is 0 otherwise. Okay, otherwise. So these in this case, in this decision boundary, sort of these 2 points will satisfy the equality that is present here, right? Yeah, so this in this question in this position it will satisfy this equality, and hence these 2 points that are on the line will actually be predicted as 1, and others will be so this will be predicted as 1, this will be predicted as 1, and this will be predicted as 0. So this is not correct, right? This should be all these three should be predicted as 0, and this should be predicted as 1. So again, so because of this reason, this line would this is also not a correct decision boundary. Remember, there is a equality here that you need to keep in mind. Okay, and then there is a final option that is actually correct, and it is basically a line that goes like this. Okay, and yeah, so it goes like this, and this is correct because since this point 1 comma 1 lies on this line, it will be assigned 1, and since all of these points which are on the other side of the decision boundary, these will be assigned as 0, and hence this hyperplane will work fine. Okay, so let me draw the correct decision boundary. So the correct decision boundary is the following. Amongst the given option, as we had discussed in the last tutorial, there can be several correct decision boundaries. For example, if you draw a decision boundary like this is also fine, right? Okay, again, easy question, not a difficult one. Yeah. So now comes the seventh question, right? Yeah. So many people last time were asking me to do this question, so maybe I will solve it today. So let me see how many people are there. Three of them. Okay. Cool. So so let us solve this. This is actually a pretty simple thing. Okay, it's not a difficult question. So what are you given? You have been given x1, which is 0 comma minus 1. So you are given 4 points. Let me just write down the coordinates of these 4 points. X2 is minus 1 comma minus 1. X3 is 2 comma 3. And x4 is 4 comma minus 5. Okay. And the labels that are given to them, that are assigned to them, are 1, 1, minus 1, and 1. Okay. Okay. Now, what is there anything else? So, yeah, so we are also given that the initialization of the hyperplane is W naught, which is 0, 0. Okay. Okay. So first of all, whenever you are given something like this, you should check that, okay, are these points even linearly separable? Can I even separate them? That is the first thing that you should check. Okay, and let us see. I mean, just plot them, and you will be able to see it, right? Yeah. Okay, so this goes there. Let me just extend this line. So, so there are points which are so there is one point at 0 comma minus 1. So there is one point here 0 comma minus 1. There's one point at minus 1 comma minus 1. Okay, this is that point minus 1 comma minus 1. Is this correct? Yeah. There is x3 which is at 2 comma 3, which is 2 comma 3. So somewhere here, okay, 2 comma 3. Yeah, and there is a fourth point which is 4 comma minus 5. So 4 will be somewhere even more here, okay, and 4 comma minus 5 will be something like this. Okay, so you have been given these points, and these 3 points, 0 comma these three are assigned a value of plus 1. Okay, this is plus 1, this is plus 1, and this point which is here has been assigned minus 1. So you can see that, okay, there are several hyperplanes that can separate these 2 points. Okay, so yeah, I mean, at least we are sure that uh, this point is at least okay. I mean, it is good. All right. So let us start running our perceptron algorithm. Okay. Uh, I hope if there is any question, right, you can just unmute yourself and tell me that you haven't understood something, or you have some issues. Okay. Nonetheless, let's start the perceptron algorithm. It is written that you have to, take uh, your points in a sequential order from x1 to x4. So let us take x1 first. Okay. So okay. So let us see what is okay. So let us see what is W naught transpose x1. Okay, which is this will be sorry, 0 0, and this is 0 minus 1. This will be just 0, right? And since 0 is greater than or equal to 0, right? Remember the perceptron algorithm. When we have a positive label, we check if the output is greater than or equal to 0, right? Since it is greater than or equal to 0, we don't update anything. We leave the W as it is. Okay. So I think you will agree that there is no update required here. So W1 will be, so the subscript here implies how many samples we have seen till now. Okay, some more person. Okay. So W1 will remain as it is. There won't be any change. Okay. Now let us see. So now x2 will come, right? So now what will be W1 transpose x2? This is again 0 0, and x2 is minus 1. This will again be 0, which is again greater than or equal to 0, which is, we check this because the label is positive. Okay, so since the label is plus 1, we just check if the output is greater than or equal to 0. Just remember the perceptron algorithm, what it asks you to do, just follow that. So since this condition is satisfied, we won't. So we will say, okay, this is fine. Let us go. So I will set my W2, which is again 0, 0. Why 0, 0? Because I haven't updated anything. Okay. Now I will again do this thing. I will check W2 transpose x3. Okay. So I will check what is the value of W2 transpose x3, and I will see that okay, it is 0 0. Now x3 is what, 2 comma 3, right? This is what it is, and the output of this is 0. But well, now here is the problem, right? That you get 0 as output, however the label is minus 1. Now you, so there is an error now. Okay, whenever you encounter an error in the negative label, what you do, you just subtract that point from your current weight estimate. Okay, so what will you do? You will say that okay, I have, so this is an error. Okay, whenever you encounter an error, what you do, you do the following. You take W3, the which is the iterate in the next, which is the next weight. This will be W2 minus x3 is what you will do. Since why minus x3? Because it has a negative level, which is minus 1. And this will become what, 0 0. W2 minus x3 is 2 3. So this will become minus 2 comma minus 3, right? This is what it will become, and hence W3 is minus 2 comma minus 3, right? I hope this is clear. Okay. And next, so now you can see, right, that okay, W, okay, let us see. So okay, now you have your W3. Now you will check what is the value of W3 transpose x4, right? What is the value of it? Minus 2 minus 3 is W3 transpose. What is your x4? X4 is 4 minus 5, right? 4 and minus 5. So what will this become? This is 4 minus 8 plus 15, which is 7, which is greater than or equal to 0. And since since the label is the label here is plus 1, this is the condition that needs to be satisfied, and it is being satisfied. So you don't have any issues. Now you can further check. Okay, now you will again go to x1 and check whether so let me just write that. Since there is no update here, W4 will be as it is, the minus 2, minus 3. Now you will again go to x1, and with this new w, you will check whether w4 transpose x1 is, satisfies this condition or not. Similarly for x2 and so on. What you will say is that now the slope, so now all of these conditions will be satisfied. What it means is that, you have learned a classifier which perfectly separates these points. So there is, so the class, what is the classifier? Let us, try to write the classifier. The classifier is basically w transpose x. Now your w transpose x is minus 2, minus 3, minus 2, minus 3, and let us say your x is like x1 and x2. Okay, what will this become? Minus 2x1 minus 3x2, and since there is no bias term, this should be, like, you can equate this to be 0, and you're basically what you are getting is x1 is equal, so x2, let me write it in terms of x2, it is minus 2 by 3 x1. Okay, or you can write it as y is equal to minus 2 by 3x, like if you are comfortable with y and x. Okay, so this is your y and this is your x, and this is the line, right? So let me plot the line. Minus 2 by 3 is will go something like this. Okay, something like this, and you can see that this is a hyperplane, which correctly classifies these 3 points on one side and this point on the another side, and hence it is a good enough decision boundary, and you won't see any update in your perceptron algorithm from here on. So though it is written, though you are asked the value of w naught after two updates, there is only a single update that will happen, and that will be in this case. Okay, in other cases it won't change, and hence you won't see any update, and hence the final answer will be minus 2 comma minus 3, which is this one. Okay, so let me write that this is the answer. So I hope this is clear. Okay, so this was the seventh question. Okay, now let us go to the eighth question. The eighth question, in eighth question, you have been given a data. You have been given a table with data, and you are asked if you can classify every label correctly by training a perceptron algorithm by assuming a bias to be 0. Okay, so let me write down the data that is given to us. So the data is following: x2, x1, x2, and there is y. So x1, x2 is 2, 4, 1. This is 3, minus 1, minus 1, 5, 6, minus 1, 2, 0, 1, minus 1, 0, 1, minus 1, 0, 1, minus 2, and 1. Okay, and let me just draw my coordinates here. So these are like very simple questions, right? You just need to check whether the data points are, linearly separable or not. Okay, so let us see. So this is so okay, so this is my x1 axis, this is my x2 axis. Okay, so I have to go to 2 comma 4. Okay, okay, so let us say that this is my 2 comma 4 point. This has been given 2 comma 4. Okay, this has a sign of plus 1, so I will be denoting plus positive labels with red points and negative labels with some other color. Okay, so then we have this point which is 3, minus 1, minus 1. Okay, so I will go 3 steps here, minus 1 step downside, and this will be like 3 comma minus 1. So this has a negative label. Then we are given another point which has a negative label, 5, 6, minus 1. So I will go till 5. Okay, and then I will go to 6 somewhere here. Okay, 5 comma 6, and this again has a negative label. Then you have 2, 0, 1, which is go 2 steps here, 0 steps ahead, and like this is 2 comma 0, right? And it has a positive label. You then have minus 1, 0, 1. Okay, minus 1 comma 0 is this point, and it has a positive label again. Then you have minus 2 comma minus 2, right? So this is somewhere minus 2 comma minus 2, and it again has a positive label. Okay, so first question will be, are these points like linearly separable or not? So yeah, you can see that there is you can draw a hyperplane like this, and this hyperplane will correctly sort of classify the two clusters. However, it is given to us that the bias here is zero. Bias is zero. So this is something that is an issue. When your bias is zero, right? You cannot. So this hyperplane that we are talking about has what is the bias? Bias can be seen as the point where the it intercepts the y-axis. In this case, the x2 axis. So it is a non-zero bias. Okay. In any case, whatever hyperplane that you will draw, no, it will have a non. So it will have a non-zero bias. However, in our case, it is given that the bias is zero. Hence, with a zero bias, it is not possible. Not possible. If bias was not equal to zero, right? If bias had not been zero, then it would have been possible. So with the current constraint, yeah, no, you cannot classify every label correctly. Okay. So this is like some minute details that you need to keep in mind while you are solving these things. Okay. Okay. So let us see the next question. So I think we are delayed question. Yeah. Okay. Let us see the ninth question. What is the ninth question? Suppose we have a Boolean function that takes five inputs, x1 to x5. We have a MP neuron with parameter theta equal to 1. Okay. For how many inputs will this MP neuron give output y equal to 1? Okay. Okay. So someone. Okay. So again, this is more of a combinatorics question. Okay. So let me write down the question first. Okay, this is a good question, and I mean it is actually a simple question, but it is like a combinatorics question. It is more of a It is more of combinatorics than you know uh, uh, machine learning or perceptron, so to say. So what is given to you? Okay, so there are five inputs. So there is x1, x2, x3, x4, and x5. So this is an MP neuron. So all of them are like aggregated. Okay, so let me draw that aggregator first. So all of them are going here. Okay. There is some theta that will be applied, and that theta is equal to 1. Okay. And you will be given some output. So so what will be the y? Okay. So y. So let us, whenever you are given an MP neuron, see the conditions on which at which the neuron will fire. Okay. So there are two conditions. Basically, if your summation xi is okay, so x1 plus x2 plus x3 till till summation till x5, if these are greater than or equal to 1, the output will, okay, I should write it like this. So this will be 1. Otherwise, it will be 0. Otherwise, okay. So the output is 1 only when your summations, are greater than or equal to 1. Okay. And since these are okay, so now we know that y is equal to 1 only when summation xi is is greater than or equal to 1, which implies like x1 plus x2 plus x3 plus x4 plus x5 should be greater than or equal to 1. So in combinatorics, it is also called the beggar's problem. Okay. But let me not confuse you there. Let me just come straight to the logic. So you know that each of these so each of xi's can either be 0 or 1, since these are Boolean inputs. Okay. So if I want this summation to go above 1, at least one of them should be equal to 1. Okay. I hope you can. I hope you understand my point. That at least one of them should be 1. Let's say x1 is 1 and the rest of them are 0. Okay. Then the output will be 1, and since this is greater than or equal to 1, the y would this would imply that y is 1. Okay. So at least one of them should be 1. If more than one exercise is 1, so let's say like these two are 1 and rest of them are 0, then this will be equal to 2, which is again greater than equal to 1, then this will imply that y is equal to 1. We are happy with this as well. But if we have any case in which all of them are 0, this the output will be 0, and hence it won't be greater than equal to 1. This would imply that y is actually equal to 0. I hope you can see these things, okay? So I hope I am clear. If I am not clear, then maybe just unmute yourself and ask questions. So I hope this is clear, okay? So like the question then is like, so this is basically a counting problem. In how many cases will mean, so think of it like this, okay? So like you have five buckets in some sense, okay? You have five buckets, and in at least one of them you need to have one of them should be filled, is what we are asking, right? There are five buckets, and at least one of them should be filled completely, and rest of them we don't care. It's like that. If more are filled, then we are happy, but we don't want any of them to be like completely uh, empty. So how do we calculate these things? So we resort to combinatorics. So if you remember, so let us say the case, so let us make cases, right? Case 1, only one xi is equal to 1. So what is this case? This case tells you that, okay, how many ways are there in which only one xi is 1. So this is like simple, right? So you have five xi's, you need to choose one of them, right? So 5 choose 1 is the answer, right? Similarly, you can create case 2, right? Which is 2, okay, it's only, right? Hmm, okay, let me do this. So 2 xi are equal to 1. How many ways are, in how many ways can two of them be equal to 1? So there are five of them. Choose any two of them which are supposed to be 1, and that would be the answer. Similarly, I hope there will be case 3, case 4, and case 5, okay, where 3, 4, and 5 xis will be supposed to supposed to be equal to 1. And what would be the number of ways in which this is possible? It will be 5c3, 5c4, 5c5, okay? And since we have to take all the possible cases, we need to sum these, okay? So you need to just so the answer that will be number of ways will be 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5. So actually now you can, so I hope that you remember that NCR is equal to n factorial over r factorial into n minus r factorial. So this is the standard combinatorics, okay? If you don't remember, maybe brush it up, because it is something that should be it is like ABCD for people who do you know CS in general. You should not forget these things. Okay, so right, so this is what it is. Now, how do we calculate this sum? So one way is to just substitute, calculate each of them, and you can sort of come up with the final answer. But since it is a less number, 5 is relatively a smaller number, you can actually do this. You can actually calculate each of them and calculate the final sum. However, if let's you are given something like 32 or 100, like 100, calculating 100 factorial using this formula will be cumbersome, and you will face some problem there. So let me tell you a trick to calculate any of these such sums, okay? So the trick is the following. You look at the expansion of 1 plus x raised to 5. I hope you remember that this is nothing but 5c0, but 5c1x plus 5c2x square plus 5c3x cube plus 5c4x raised to 4 plus 5c5x raised to 5. This is what people call this as a binomial expansion. Okay. Now substitute x to be 1. Okay. Why am I substituting it to be 1? Because I can see that, if I substitute x to be 1, this will become 1, this will become 1, this, all of these will become 1, and I will get my sum 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5 and so on. But I will also have an extra term here, and like we can deal with it. So if we substitute that, this will become 1 plus 1 raised to 5. This is 2 raised to 5, which is equal to 5c0 plus 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5. And this is the sum that is desired, that we want to calculate, and hence this will become like summation 5ci, I goes from 1 to 5, will become 2 raised to 5 minus 5c0, and 2 raised to 5 we know is 32, minus 5c0 is 1, hence this will become 31, right? So the answer will be 31 in this case. Okay. So it's like this is just something that will come in handy when you are dealing with larger values of n. Okay, I mean, if you have any question or some part of it was too much to grasp, maybe you can either just unmute yourself, or maybe you can also write in chat. But yeah, anything would work. Okay. So this is completed. Now let us come to the 10th question. The 10th question basically asks you, which of the following algorithm is used for training a neural network? Which of the following algorithm is used for training a neural network? So the options that are given are as follows. First is decision tree. Decision tree. B is Newton method. Method. C is back propagation, and D is lasso. Okay. So decision tree is an algorithm which it is itself a machine learning algorithm. Okay, but it is not used to train anything. It is a tree that we are supposed to train, but it is not the algorithm that is used to train a neural network. So this is not a correct answer. Then we have Newton method. Newton method is actually an optimization technique, but it is an optimization technique, but it is not used to train a neural network. So it is something that is used in optimization, though neural network learning a neural network itself means optimization, but it is still not the technique or the algorithm that is used. It might be the final optimization thing that we use, but it is not the algorithm that is used to train a neural network. So this is also not correct. Then we have back propagation. So back propagation is the algorithm that is actually used. Okay, maybe remember this. I mean, you will use it every now and then in the later weeks. So backprop is like it's like simple. It's not a simple thing, but it is how to efficiently calculate the gradient of the loss function with respect to different parameters of the network. That algorithm is back propagation. And then this is lasso. Lasso is again a regularization method, and it is not the correct answer. So it is just like GK. You need to remember this thing. Okay, so I think we are done with week 1 questions. Okay, so week 1 is done. So this ends week 1. All right. Okay, so if you have any questions, maybe you can unmute yourself, or write in the chat. Let me just have a sip of water. Okay, so I can't see any questions or raised hands. So maybe I will move forward with week 2. Okay. Okay. Okay, so this was week one, right? Okay, so I have covered these things. Okay, so let me go forward with week two. Okay. Okay. Okay, so let's get started. Okay, let us not waste any more time. So now I will just increase my speed. Okay, since I think since you are not asking questions or anything, maybe I am explaining a bit more than required. Okay. So let us see the first question. The first question is asks you how many Boolean functions can be designed for four inputs. Okay. So you know you have when you have four inputs, how many possible outputs can be there? You know, I mean, if you have like it's like you have, let's say, x1, x2, x3, and x4. How many possible pairs can I prepare? So I know each of them can have two values. Okay. So if I take the combination of all the possible values, it is going to be 2 into 2 into 2 into 2, which is going to be 2 raised to 4, which is 16. Okay. So this is like the total number of different values that I can have for these four inputs. Okay. So it's like 0 0 0, like again like 0 0 0 1, and till like 1 1 1 1. So these inputs, all the possible combinations are going to be 16 in number. Okay, these are 16. And now how many functions can be there? Okay, so again think of it like this, right? There, so if one is given to create any function, what that person can do is it can either add, like it can assign 0 to this to this input, or it can assign 1 to this input. Again, this the one can assign either 0 to this input or 1 to this input. Similarly, this can be assigned 0 or 1. So if I have to create a function, I only have two options for each of these inputs, right? So any input uh, I can either make the output to be 0, or I can make the output to be 1. So there are only two possible ways, right? Then what are the total number of functions that I can make? So it's simple. So it's like there are 16 elements, okay, right? And each of them can have two values, can be assigned two values, either 0 or 1. So it will be like uh, it will be like something like this. Okay, so if you have 16 possible inputs, the total number of function will is going to be, the first input can have either 0 or 1, so two values. Similarly, the second input can have either 0 or 2, again two values. Similarly, till 2, this thing will happen 16 times, right? So this is going to be 2 raised to 16, right? And uh, if you look at it, what is 2 raised to 16? I think it is given the options. There is only one. So it is. I know that 2 raised to 10 is 1024, right? So it is definitely going to be above 1024, and there is only one option that is above 1024, which is 65536, right? So this is the correct answer. Okay, so 65536 is going to be the correct answer. I hope I was clear. If not, please let me know. Okay. Moving on, the next question is the second question. The second question asks us, we have a classification problem with labels 0 and 1. We train a logistic model and we find out that W0 is learned by our model. W0 learned by our model is minus 15. We are to predict the label of a new test point X using this train model. If W transpose X is equal to 1, which of the following statement is true? Okay, so there are two labels. Okay, fine. So, okay, so W naught is given to be minus 15, and we are given that for a particular input, W transpose X is given to be 1. Okay, So I hope you remember that the logistic function that is that we have learned is something like this, right? 1 over 1 plus e raised to minus w transpose x plus w naught. Okay, this is the logistic function, and depending upon its value, if it is greater than zero point 0.5, you predict some 1 as output. Uh, if the value is less than zero point 0.5, you predict 0 as output, right? So let us see. So there are two things that are required to calculate this, right? So one is W naught, which is given to us, okay, and the other thing is W transpose X. We have been given that as well, okay. So we can calculate this value. What will this become? 1 over 1 plus e raised to minus. So W transpose X is 1 minus 15, okay, and this will become 1 minus 15 is minus 14, and 1 plus minus 14 minus minus plus, and it will become something like this. And I know that e is greater than 1, okay, and so e raised to 14 is going to be like much, sorry, it is going to be much greater than 1, right? So 1 upon 1 plus something that is much greater than 1 is going to be less than zero point 0.5, right? Because if your denominator is very large, the entire number becomes very small, okay. So this is since this will be less than, since f of x is less than 0 0.5, the output y is going to be 0. So which option is this? Label of x predicted by the model is 1. No, the second option is label of x predicted by the model is 0. So yeah, so the second option will be right. Third option is not enough information provided. No, we have all the information that is required, and we have only these two things are required. And fourth option is label of x predicted by the model is 0.37. So remember that the output, when you calculate it, you need to threshold it, okay. You just need to see if the output is greater than zero point 0.5 or is it less than zero point 0.5. If it is greater than zero point 0.5, then output 1. If it is less than zero point 0.5, then you output 0. So that was a simple thing to just keep in mind, yeah. So coming to the third question, suppose we have a function f of x1 comma x2, okay, which we want to minimize. The given function using the gradient descent algorithm, we initialize x1 x2 to be 0 0. What will be the value of x1 x2 after two updates of the gradient process? Okay, so this is again a similar question to that of the perceptron algorithm, which is you need to just follow the algorithm that is there. So let me do that. It is again a simple one. Nonetheless, I will do it because people are generally afraid by seeing such big things. These are literally puny things. Okay, so f of x1 comma x2. What is it given? X1 square plus 3x2 plus 25 is what it is. Okay, and you are given that x1 comma x2 at 0th, I mean initialization. This is 0 comma 0. Okay. So I hope that you remember that gradient descent, how it works. What you will do is x1 you will update as x1 minus some eta times. Eta is given to be 1 here, so 1, something like eta times gradient with respect to x1 f of x1 comma x2, right? So something like this. Okay, and similarly we do this for x2 as well. So x2 minus eta times gradient with respect to x2 f of x1 comma x2. Okay, since eta is given to be 1, okay, I can ignore this thing. Just let me get rid of it. This will be as it is. Okay, now let us calculate gradient with what will be the gradient with respect to x1 of f of x1 comma x2, right? Let us calculate this. So you have this thing which is dependent on x1, which is this thing is dependent on x1. This will become 2x1. These things are not dependent on x1, so they will like become 0. Okay, similarly gradient with respect to x2 of f of x1 comma x2. So in this case, only this term is dependent on x2. This term and this term will go to 0. because they are not dependent on x2. Hence, this will become what? 3. 3x2's differentiation with respect to x2 is 3. So, so this is fine. So, if I substitute these two things here and here, right? What will this become? So this is what it will become. X1 will be equal to x1 minus 2x1, and x2 will be x2 minus 3, right? And this becomes minus x1, this becomes x2 minus 3 as it is. Okay, so whenever so at each step I will substitute I will change this. So I will, if x1 is, so let me do it. Okay, it is better, I will better write than saying it. So what we are given is x1 comma x2 at 0th hit rate is 0 comma 0. Okay, so I know that x1, I have to update it as x minus x1, right? Which will be minus 0, which is nothing but 0. And x2, I have to update as x2 minus 3, which is 0 minus 3, which is minus 3, right? So what this tells me is that x1 comma x2 at first, after first update, will be 0 comma minus 3, right? Let me write this thing here as well. This is what we get. Okay. So this was the first update. Now I will again do the same thing. X1 is equal to minus x1. It will again, since x1 is 0, it will again be minus 0, and it will be 0. In x2, I will subtract 3 from it, x2 minus 3, which is minus 3, which will become minus 6. Hence, this tells us that x1 comma x2 after second update is 0 comma minus 6. So 0 comma minus 6 is the final answer that we get, right? And do we have that option? Yeah, we do have that option. The first option is 0 comma minus 6. Okay. Okay, so I hope this was clear. Okay, so this was the third question. If you have any question, I'm repeating this again and again, but okay, there's no harm in it. So if you have any question, just unmute yourself and you can ask. Okay. So like you should not be ashamed to ask anything. It's like these tutorial sessions are meant for you to ask questions. Okay, so I have to see the fourth question. Okay, so you have been given a diagram in the fourth question. Okay, and the y that is there, they are saying that it is 1 over 1 plus e raised to minus. So it's your logistic function is what it is. Okay. Which of the following statement is true with respect to the above diagram? Okay. Blue line. Okay, so let me draw that diagram first. Okay. And what I have been given is there is point 0.5 here. Okay. There is this line. Okay. And there is 14 here. Someone is trying to enter after so long. Okay. So there is 14 here. So let me draw this line so that I make sure that it exactly intersects it. Okay, so this is y, this is your x, right? So okay, so this is your w transpose x is what they are saying, right? And this is your function that is going something like this. Sorry, this is something like this. Yeah? Okay, so we have been given that this is so this point at this point, right? W transpose x is given to be 14. Okay, and this is the same point at which y is also equal to like 0.5, right? We have been given 4 options related to w naught. So this is again an easy question. What you need to do is just substitute these values in this function. Like the value of y, so substitute it here. You know the value of w transpose x, substitute it here, and then you will know something about w naught. So let's do that. Okay. So you have been given 0.5. So y, which is equal to 0.5, is equal to 1 upon 1 over 1, 1 upon 1 plus e raised to minus w naught. W transpose x we know is plus 14. Okay, am I correct? Yeah, right. So this is what it is given. So what I will do is I will just take inverse on both sides. This will become 2. This will become 1 plus e raised to minus w naught plus 14. I will take that here. This will become 1 is equal to e raised to minus w naught plus 14. Yeah. This will tell. So now I can take log on both sides. So log 1 is 0 and log with a natural logarithm of this thing will become minus w naught plus 14. Right. And hence we will see that w naught is nothing but minus 14. Okay. So w naught is equal to minus 14 is the correct, will be the correct answer. Okay. Right. So again, easy problem. You just need to see the graph and interpret what is written, and just see the x-axis, what is the y-axis, substitute these things in this formula, and rest is easy. Okay, so moving on, the fifth question. What is the fifth question? So the fifth question asks you, how many neurons do you need to in the hidden layer of a perceptron to learn any Boolean function with 5 inputs? Okay. So, okay, so this is a perceptron, right? So let me write that down. So there are 5 inputs. So 1, 2, 3, 4, 5, right? And there has to be certain number of there has to be certain number of uh, neurons here. I don't know how many neurons here. Okay, and there should be one neuron, so one output neuron. Okay, and this should give you the output. Okay. So this is again a counting problem. Okay. So how many possible inputs can be there? So this can have a value of 0 or 1. This can have a value of 0 or 1. Similarly, this can have a value of 0 or 1. Similarly, this and similarly this. So each of them can have two possible values, 0 or 1. So how many total combinations can be there, right? So so if you see this thing, okay, so number of possible possible inputs, right? What will it be? We saw, right, this is nothing but 2 raised to 5, because since there are 5 of them, each of them can have two values. It will be 2 raised to 5, which is 32, right? And if we have 32 neurons here, right, 32 neurons, each of them is assigned to one input, right? So let's say all zeros is assigned to this first neuron, all zeros except one is assigned to this neuron, and similarly when all of them are one, these are assigned to this neuron, they can easily and we can fire the neurons only when that particular input is given as, that particular combination is given as input. We can make that function, right? I hope like I'm clear. It is very simple actually. So the answer is 2 raised to 5, which is 32. Just look at the total possible number of possible combinations that can occur here. That is all you need to see. Again, if I was not able to explain it correctly, maybe you can unmute yourself and ask a question. Okay. So this was the fifth question. Uh, Let me see the sixth question. What is the sixth question? Sixth question asks you, given the below graph below, which of the following model will best learn the relationship between input X and output Y? Okay, so let me draw that function that is given to you. So this is the function. Yeah. So this is your X, this is your Y, and you have been given something like this, right? This thing is going here as something like this. I hope I'm correct. Yeah. Okay. So in questions like this, you always need to check the options and see which of the options makes sense. Okay. So let us see the options one by one. Okay. So the first option is y is equal to w transpose x plus b. Okay. So so w transpose x plus b is a linear line. It's just a simple line. So okay, I can see that if I make a line something like this. Oh, this is not something like this. it will be able to approximate the this part of the function. However, this part of the function won't, we won't be able to, approximate this part. So that actually poses an issue. Right? I hope I am clear that if you make a function like this, maybe you can approximate this part correctly, but this part won't go through. Similarly, maybe if you say that, okay, you said this is a problem, I will make this function, right? This is a linear function now. So okay, this part is maybe approximated correctly, but this part is left out and you won't be able to manage that, right? So I hope you can agree that this is not a good choice. Okay, so you won't be able to approximate it. Coming to the second option, y is equal to w transpose x square. So what will w transpose x square look like? It will be like it is, so think of it in one dimension, right? So w is, let's say, a constant, like something like 1. So y is equal to x square kind of thing. So how does a quadratic function look? So quadratic function looks something like this, right? You need to remember these things, by the way, okay? That how does a quadratic function looks like, how does a linear function look like, how does a parabolic function maybe looks like. So you can see that, if given quadratic function something like this, again you are able to correctly approximate this part of the function. However, this part of the function is left out and you are not able to manage that. So I hope you will agree that this is not a great choice. This won't be able to exactly uh, sort of approximate this function. Okay. So again, so this is also not a good option. So what is the third option? Third is y is equal to w transpose x raised to 12 plus b. Okay. So again, this function is again, like think of it, make this as 1. Okay, so it's like x raised to 12 plus some constant. And this function, what it will do is it will just, so this is just a bias term that will shift the curve. But I mean, if you have some idea of how the graphs look like, this function will again look something like this. Okay, similar to what, so similar to x square, but instead maybe x square looks something like this. X raised to 12 will be even more steeper, something like this. Okay, that's the only difference, perhaps. Yeah, yeah. Am I correct? X raised to 4 plus b. Yeah, I think I'm correct. Yeah. So again, this won't be able to, correctly approximate the function. So this is also not a good option. The D option is y is equal to e raised to w transpose x plus b. So this is again a weird looking function, right? So let us see how does w transpose. So w transpose x goes in the exponential, right? So let us see how does w transpose x first behaves, right? We saw that w transpose x would behave something like this, okay, some line like this. Okay, so let me, what I will do is I will just create a, proxy line here. So let us say this is the w transpose x, like, okay. Now I have to take exponential of this. So if you see in the positive part, the exponential function actually grows. So let us remember that, the exponential function looks something like this. Okay. In the positive part, it grows exponentially. So in the positive part, it will have some behavior like this. Okay. However, what happens in the negative part? The negative part, you can see here, right? The function, the exponential function actually decays. It won't, go. First of all, it is positive. It is always above y-axis, and it decays. It sort of goes to zero slowly. So when the value of w transpose x is like less than zero, which is this part, it will decay something similar to this. Okay, so it's like in the positive part it will have something like this, something like this, whereas in the negative part it will decay. So I think it does make sense, right, that this kind of function might be able to, approximate your given function. So it seems like this is the correct option. So So I am just solving this question how I would have solved it. There might be some correct method to solve this thing, but since you are doing an MCQ kind of thing, you should always see how you can exploit the options and sort of overcome these questions. Okay, so these are just trickery that are there. I am just trying to show you how you can do it. There might, if you are, there might be some better way, some mathematical way, but trust me, mathematical ways might be overwhelming in MCQs. So it is better to resort to heuristics. Okay. Okay, coming to the seventh question. So the seventh question says that you are training a model using gradient descent algorithm. You observe that the loss is decreasing, then increasing after each successive epoch. Okay, which of the following techniques will you use to increase the chance of convergence of the gradient descent algorithm? Okay, so what it is saying is that initially loss is decreasing. Later on, loss is increasing. This is what it says. Okay, so let us think about it. So when is it possible that the loss is initially decreasing, but however later on it starts to increase? So it must be something like this. Okay, so let me give you an example. So suppose your loss function is something like this. Let's say, okay, it does look weird, but okay, bear with me. So let's say you started from here, okay, and you had some step size. You took some step size, you came here. Let us suppose that you had a high step size earlier, okay. Now again you took some step size, you again took some step and you came here, okay. You again took some step here. Maybe let me create that diagram again. So what I'm trying to say is something like this, something similar to this and something like this. Yeah. So earlier you were here, you took some step, you came here, okay. Then again you took some step, you came here. Again you took some step, you came here. You took some step, you came here, okay. But now, since you were, it was desired that you went here, okay. But now since your step size is high, you jumped over this value and you came here, okay, something like this. Now again, and somehow you are now basically stuck in this minima. So you are kind of seeing something like this. You are not, since your learning rate is high, basically since your learning rate is high, you are stuck here in this bottleneck, and because of that you are not able to reach the minima which is here. So in these cases what you do is you should decrease your eta, decrease the value of eta. So there are four options. First is increase the value of eta. So you can see, if I increase the value of eta, I will only make bigger jumps, right? I will go maybe perhaps here, and like maybe you will go something somewhere around here, then you again jump back here, things like that will happen, and that is not desired. There is another option which tells you set eta to 0. So as soon as you set your eta to 0, you won't move. So like for example, if you are here, you will be stuck here, you won't move upward, neither will you move downward, you will just stay where you are. And there is another option which says that set eta to 1. Well, setting eta to 1 is not I mean, we don't know what the curve is like. This thing that I made is just a for example's sake. I mean, it might be a weird thing. Who knows what the value of eta should be? So the best option that we have is decrease the value of eta. So whatever step size is, maybe if your step size was this big, now maybe decrease the step size to like this. So maybe you are able to go towards the minima now, and then you will encounter the global optima. So the correct option here is decrease the value of eta. uh, any questions, anything? If you have, just unmute yourself. So seventh question is done. So three questions remaining. Okay. Eighth question. What is it? So we have a function that we want to approximate using 150 rectangles, towers. How many neurons in the hidden layer are required to construct the required network? So again, be careful while doing these questions. Okay, so I hope you know that when you are given the, so let us say you have, so how do you create a rectangle? I hope you remember that you take one sigmoid something like this, then you take another sigmoid which is shifted a bit but something like this, and you subtract these two. Okay, and then what you get is something like this thing. Yeah, and that is how a rectangle is created. So what is the idea here? You give x1 to two neurons. Okay, so each of them will give you something like this. Then you sort of subtract them, and then what you get is a rectangle, right? So how many neurons are involved in one tower? This is the first neuron, this is the second neuron, and this negative, that subtraction, is also another neuron. Okay, so for one rectangle, three neurons are are uh, required. And you have been given how many rectangles? For 150 rectangles, how many? 150, sorry, 150 into 3, which is equal to 450 neurons are required. Okay, I hope so. So many people, what they do is they forget this subtraction neuron. Okay, maybe because of this, some people might not be able to reach the correct answer. Okay, yeah. So this is ninth question. Ninth question is the output layer of. Okay.
Sir, please explain the eighth question again. I just missed it. It went wrong in my assignment.
Okay. Let me clear that question. So I hope you remember that how a rectangle is created. So the way one constructs a rectangle is we create two sigmoids, one like this, one like this. Okay. So this one is like let's say some point A, and this at some shifted point A plus B. Okay, and then we
Yes.
subtract these two functions, right? We subtract these two functions. So what will happen when we subtract these two functions? So so if this is the first sigmoid and this is the second sigmoid, I am making both of them on the same graph. This part will subtract to 0, this part is already 0, and so what will remain is this part, right? I hope you agree.
Okay. Okay, sir. Yes, sir.
So what you will get is this part, right? Whatever remains here. Okay, so this
Okay.
part is what you will get, right?
Yes, sir.
Yeah,
Yes,
so
sir.
this is what you will get, right? I hope you agree. So how many neurons did it involve? So you gave some input. So the first neuron created this sigmoid, the second neuron created this sigmoid, right? And then you subtracted these two sigmoids, which was done by this neuron. So there were in total three neurons that were involved: this one, and this one, to create a single rectangle. Okay.
Okay, sir. Yes,
So
I
since
worked on
three
two
neurons,
neurons. That's why the answer
yeah,
came
yeah.
out.
Yeah. Generally, people just consider these two neurons and they ignore this one. However, this is also a neuron that you need to, keep in mind.
Okay, sir.
Hence, right? So one
So three
rectangle
neurons.
requires three neurons. Yeah. So 150 rectangles will require 150 into 3, 450 into
Yes, sir.
3.
Thank you, sir.
Okay. Okay. All right. So, so good. Someone asked some question. Otherwise, I was feeling like I'm doing a skit here. Okay. Nonetheless, ninth question, what it asks you is the output of a sigmoid neuron has the following values for the inputs. Okay, okay. So x1, the output is 0.9. For x2, the output is 0.1. x3, the output is 0.49. x4, the output is 0.63. x5, the output is 0.33. Okay. What will be the label predicted by the sigmoid neuron for each of the following inputs? Okay, so just remember that what a sigmoid does is, So just remember what the sigmoid does is it will first of all, so let me just write y, whatever the output of neuron is, the output will be such that if f g of x, if this is like just a second, okay, let me move this thing. So what is the output? It is 1 or 0 if the output of the sigmoid is greater than or equal to zero point 0.5 if f of x is less than 0. So if the output is less, if the output is less than zero point 0.5, the output will be 0, right? And if the output of the logistic function is greater than zero point 0.5, the output will be 1. So it's like a thresholding function. Once you apply the sigmoid function, you see what you just threshold it with zero point 0.5. So all we need to check is whether the particular input is greater than zero point 0.5 or less than zero point 0.5. So zero point 0.9 is greater than or equal to zero point 0.5, right? So the output will be 1. This zero point 0.1 is less than zero point 0.5, hence the output will be 0. 0.49 is again, less than zero point 0.5, hence the output will be 0. 0.63, it's 0.6, yeah. If this is greater than or equal to zero point 0.5, so this output will be 1. This is less 0.33 is less than zero point 0.5, so the output will be 0. So the correct option answer should be 1, 0, 0, 1, 0. I hope like this is a simple thing. Just see if it is greater than or smaller than zero point 0.5 and accordingly take the decision. Okay. Okay. So final question. Okay. Today's last question, 10th question. It asks you, what are the advantages of sigmoid decision function over the perceptron's 0, 1 decision function? Okay. So this is also a good question. Mm, okay. So for perceptron, so what is the output for a perceptron? So let's say this is your like the perceptron. What it does is, so it's like this. For perceptron, the outputs are like this, right? If it is 0 till some point, some fixed theta or something like that, and after that it is 1. This is 1. This is 0, right? Whereas for sigmoid, what it does is, if this is your threshold function, it will take it something like, it is a smooth approximation of, okay, something like this. So it is a smooth approximation of the perceptron's 0, 1 output, yeah. But what are the advantages of it? Okay, so let us look at the options again. So the first option is, it is differentiable. It is differentiable at every point. The second option is, uh, range can be extended to -100 to 100. C is, it is discontinuous, and fourth is all of the above. All of the above. Okay. So first of all, let us discard the options that are clearly wrong. Okay. So we can see from this function, right? We can see from this diagram that it is not discontinuous. In fact, it is a continuous function. Okay. So this option straightforward is wrong. It is not a discontinuous function. And since this is wrong, all of the above cannot be true. So D is also wrong. Okay. Coming to A and B option. Okay. The range can be extended to -100 to 100. Is this true? Well, I mean, so the range of the function is, you can see it's always between 0 and 1. Okay. You can maybe multiply it with 100, -100 and 100 and things like that. But I mean, it won't help, right? I mean, you can do the same thing with perceptron as well. So there is no advantage that we get by extending the range, right? I hope you agree with me. Like if I multiply this point by 100, right? And this, I can even multiply this by 100. So the upper value can go up to, let's say, +100, right? But it can be done with both for perceptron as well as the sigmoid, perceptron as well as the, sorry, sigmoid as well as the 0, 1 decision function. Whereas, I mean, there is no advantage that I get from this property. Though the property is true, but I don't get any advantage over it because of it. So this is also not correct. And so obviously the remaining one is correct, and which is that it is a differentiable function. How does differentiability gives me an advantage? Note that perceptron is not differentiable at this point because it is discontinuous. Okay, here. So this is discontinuous. Okay, hence not differentiable. So what advantage does differentiability give me? Differentiability gives me the advantage that I can apply algorithms or techniques like back propagation to come up with optimal parameters, as you have seen already in like single layered networks, right? So this is the advantage that I get from the differentiability of sigmoid function, and that is actually why we use sigmoid in general nowadays deep learning, and this function is not used, whereas this is used. So this is the correct option. Okay. So I hope I have solved all the problems. So yeah, I have indeed solved all the problems. Okay. Uh, if you have any question, just ask me.
Sir, please solve assignment 3 also.
Assignment 3 deadline is what?
Yes, sir, but if you will give answer, we will not have to work on it. As a joke, sir.
No, yeah, so yeah, but I know it could be first frustrating to see all these questions, and it can be overwhelming. But I think just try. I mean, as I told, no, I mean, should not see these things as how much score you can get. I can tell you the answers, and like you can just fill in, get all the marks, but it won't help you,
Yes, sir,
right?
theory questions are easy, but the numerical ones are a bit testing on my.
Yeah, these questions are designed to be that way actually. I mean, so that when you actually do it on pen and paper, right? When you actually write these questions, solve these algorithms and things like that, it will actually massage your brain. And when you see when you like tell me, I mean, if you have seen these things, these solutions that you get after each week, right? When you see that, okay, this is what you had done and this is what the actual answer is and how you should have done it, I mean, it actually gives you that aha moment that, okay, this is how I should have done it is something that only comes if you do it on your own. So yeah, so let's keep it that way. I mean,
Yes, sir.
okay.
Thank you,
I,
sir.
Hello. Yes, sir.
Sir, is there any reference material, sir, for us to solve the problem? Because we have difficulty as what the another participants told also.
okay,
Because all
so
the
yeah.
theory part we are able to understand through your lectures that you have NPTEL lectures. But when it comes to the problem, actually we are all new to the topic. We get struck and we feel it very difficult also to solve.
Right.
But after
So
you have told us of solving of assignment 1 and 2, we feel we could have done it very well. So your suggestion on how to improve the problematic session, what can we do with that?
okay, so I think I think are you guys following Ian Goodfellow's book? I think that is a good reference material.
No,
So
sir.
Can you please
I'm just
share
following
the
Shakti's camp. Put it in the chat, the book name.
okay, so let me just put it here. So deep learning by Ian. So I think it is there, but let me just write it. Ian Goodfellow. I think Joshua Benju is there, also one of the authors, and so Aaron Cornwell is also there, I think. So this I have written the name of the book. I think that is a good material. If you can, solve the problems from there, maybe I think you will somehow, it will be easier for you from the next sessions, perhaps. Yeah. Um, so it's so yeah, I agree that it can be overwhelming, but maybe try to maybe yeah, I think reading is something that you need to do for deep learning. Without reading, just looking at the lectures might not be sufficient. I agree with you. So yeah, perhaps reading and solving some problems from this book would be good. Yeah. Okay.
Thank you. Thank you.
Yeah.
Sir,
So
actually, I have one more thing. We have actually 3 sessions being conducted before every week.
yeah.
So actually, will any session brush up on the week 3 and week 4 materials? Actually, we have 2 assignments to be submitted every week. Is there any session like that for us?
So the way these tutorials are designed is that after you submit your week 2 assignments, okay, week
Okay.
3, week, sorry, so what I was saying, so after you submit your week 3 assignments, the next tutorial session we will discuss week 3 assignments. So it's like we won't discuss week 3 material until you have submitted the assignments, okay. Otherwise,
Okay. Okay.
what will happen is we will discuss the questions and we won't solve those problems. So that is how it is designed. Okay, I hope
Okay.
you
Okay.
understand. Yeah?
Thank you.
Right.
Yeah,
Yeah.
hello, sir.
So right. Yeah. Yeah. Go ahead.
Yeah, possible to provide previously conducted deep learning final examination papers? I mean, questions for just
Uh,
because I'm not getting what type of questions we are getting like that.
right. So I am not sure about this. What you can do is maybe ask this question in the forum on the NPTEL forum. I am not sure about this. I'm not aware if we can provide that or not. Okay.
Yeah, okay, okay. Because
So
solving weekly, I
yeah,
mean, week-wise assignments may not be sufficient for final assessment. I think so. That's why how the final assessment questions will be just for verification purpose. How these
yeah, yeah,
questions asking,
yeah,
whether
yeah.
it
So
is
maybe you can post a doubt on the forum, right? I
yeah.
can you can do. I think you can do that. So just do that. Okay.
Thank you, sir. Thank you.
Yeah. So okay, okay. Tuhin has found the book. Yeah, good. Yeah. So I think if there are no more questions, then we can end the session. Also, maybe if you guys want to provide some feedback as to how the session was, I think it was mostly monotonous because I was speaking and you were listening. But yeah, I mean, was I able to convey my points or was it very monotonous? I
Is the
don't know.
recording of the session available, sir, to us?
Yeah, yeah. So we always record these meetings and we upload it on YouTube. And NPTEL team is supposed to share that. I don't know how they should share it, but yeah.
I don't think the previous week recorded has been
No,
shared.
sir. NPTEL team is not sharing it. I just attended the IoT session also just 1-2 hours ago, and they shared the YouTube link themselves.
Okay, so maybe I will share that link. Let me, yeah, just let me share that. Okay, so I will paste the command in the chat itself.
Yes, thank you, sir.
Yeah, so this is the playlist where the previous session was recorded, and I will upload this one as well. Okay. Okay, so yeah, so if there are no more questions, maybe we can end this. Okay. So okay, so I am ending this meeting. I'm stopping the recording. Okay.
Thank you. Thank you.
Thank
Okay.
you, sir.
Yeah. Yeah. Welcome.
Thank you very much.
Yeah. Sure. Welcome.